So I'm just going to talk about BIM 5D. Promise that will not be a lot of technical stuff, just understanding the bigger picture, why do we need it and what we're trying to achieve. First, a quick brief about myself. I'm a principal consultant from Logikal projects, and I'm currently working on major projects for rail in Birmingham. So just to put things in perspective, we had several industrial revolutions, or that's what they call them. And the first revolution was about mechanization, steam engines, and all this stuff. And then we moved into the second industrial revolution, which is basically about electrification and doing that mass production. Then we moved into the industry 3, which is automation, computer, electronics, where when the computer started getting into work. But currently, there is a big emphasis on what is called Industry 4.0, and that's basically is about analytics and using the data in order to generate a lot of insights from the future and predictions of the future. We'll get into a little bit on that. I'm not diving into a lot of details about it. But that's a very nice quote that I always like to use. It's by Sir John Ahmed, and it says, data is now as important to the UK infrastructure as concrete and steel. And it is, and if we compare it to other industries like retails and wholesale, the amount of data that they hold is sold for billions, and it is valued at billions of pounds. They even say that it's more expensive than oil. So what is the problem that we're talking about? We're talking about that, I'm pretty sure that you've all seen something similar to it. We're talking about the silos, where we have all departments and each of them work on their own silo. There is a lack of integration. And what we're trying to do is to break these silos in order to work as an integrated team. There are a lot of theories behind it, but we're talking about practice and how we implemented that in real life. One of the major challenges that we're going to see is when we have a structure, and that structure has a lot of data, and the data is structured in different ways. So let's take an example of that. We have, the first one is asset breakdown structure, where the asset is broken down into several elements, and each of these elements is organized in a hierarchical order, which is asset breakdown structure. Then the planners will use what is called the work breakdown structure, WBS, where they're going to organize the work on how they want to sequence it and how the things will be implemented and used. While the cost breakdown structure goes in a completely different way, using the standard methods of measurement, either SMM or new rules of measurement, or SESM, or whatever methods of measurement that you're going to use, but it is a completely different way of structuring data. Why don't we align them and use one set of structure to fit all? In my opinion, it's not possible. And it's not possible because each one of these has its own objective. So if you look at the cost breakdown structure, the estimators and the cost managers are looking for cost centers. They need to understand how much it's going to cost me in order to excavate 1 cube of concrete. And they want to have that across the overall project, not on a particular element, which, while the work breakdown structure, they want to break it down into small areas where how the work will be executed and managed on site. So that's why we cannot align we cannot align all these structures to work together. But what we're coming to a solution, so I'm just not giving you challenges only, get you a solution later on. One other major challenge that we face in most of the project, we have a lot of systems. And these systems, they don't talk to each other. They're also isolated, they live in silos. How we can do that integration? And that's a very simplistic, very high level integration map between these systems. And in reality, I have like a line connecting each of these systems together. In reality, we have multiple lines between these systems because the integration is not done as one-to-one. It's more in change management can affect a lot of engineering drawings or design elements, not only one. So this is very abstract way of presenting the complexity. So we came up with an approach trying to solve that problem of the large amount of data and the integration between these systems in order to allow them to talk to each other. And one thing that we came up with is the building information modeling, or the BIM. So why don't we use the BIM as the center of everything, and then we start linking everything to the BIM models on a very detailed level, not on a high level. So if we have a column, we will extract the quantities of that column, concrete, reinforcement, formwork, and then when we have a change, we will identify which elements in the model are affected by that change. When you go to that level of granularity, you can align all your WBS and CBS and ADS structures in there, which we're going to show you in a minute now. So what we have achieved a lot of these. So I mean, we're still working on the risk, and the program is done. Performance reporting, I will share with you some other nice stuff in there. So the benefits, we have identified very high level benefits on short term and long term. And the short term is basically about cost saving, single source of the truth. You get a lot of automated dashboard and data produced from these models, which is all coming from the same source. So you wouldn't expect to have any conflicting information in there. Reduce time for data manipulation, so you don't have people with loads of spreadsheets crashing all the time when they try to open them because they have huge amount of data. And by the way, we have a slogan there, which is SOS, stamped out spreadsheets, no spreadsheets on the job. I know that a lot of people don't like it, but we're trying to. But more important, I mean, these are all good stuff and they are very important, but I think more importantly are the long-term opportunities. And these long-term opportunities is how to use this data, and you created the data lake, a lot of information there that you can generate from insights in the future. So we're talking about like benchmarking, informed decision making using this data, and even estimating future jobs based on the performance on the previous jobs. And that's, okay. Was slide here that disappeared, but it's basically talking about the analytics, and the analytics is how we can do prediction using historical data. That's a branch of the artificial intelligence science, but it's now part of that 4-point node overall strategy. How to get historical data, understand the pattern, recognize these patterns, and infer the future from this. And surprisingly, it's quite efficient. So I've seen some algorithms that I've done is over 90%, or even sometimes reach 90% accuracy. So that's quite high. One thing that's what I was having a discussion with one of the contractors that we work with, and he was saying that we don't have project controls. So what shall we do? And for me, it's a journey that you need to start it from the top and then mature in order to reach to the full integration and fully automated project controls. You cannot start by saying that I don't have anything, but I want BIM 5D and fully integrated with artificial intelligence tomorrow. That won't happen. So in reality, we came up with this like 4 maturity levels, if you like. One of them, which I think most of the projects are running with spreadsheet-based systems, where you start doing the integration across loads of spreadsheets, trying to link them together and trying to extract the information out of them. Then there is a lot of development now. I've seen that a lot of clients now are using the business intelligence tool to automate the report production. So instead of having the reports via people monitoring and trying to wrangle the data, the BI tool will do all this ETL, or transformation of the data, in order to produce information from the base data that we have. Then we have the integrated project control systems, where you start moving from spreadsheets to databases, and these databases can talk to each other, and the BI tool on the top will just have that layer of reporting. And the last bit is BIM for project controls that we're using. So it's a combination of BIM and artificial intelligence, as I mentioned earlier. Just have like here what we have done and what we think is the way that you should be thinking about it when you do it. So most of the time, from people coming to me and say, yeah, so which software we need to buy? BIM is not about software, it's about culture, it's about requirements, it's about change, systems, processes. So what we have said to most of the people, to most of our clients is like, let's start with understanding what is the requirements. What do you want to achieve? Instead of just saying, okay, let's go and buy this piece of software and it's going to do whatever you want. So we do understand the client requirement by just interviewing multiple people in assessing their maturity and giving them advice where they should be targeting or what they should be aiming for. Then we do a problem statement. So if we decided that, okay, now we understand fully what are your requirements, let's go and start analyzing these requirements and say, okay, you know what, we have 4 different software vendors that can meet your requirements. And then we take this and we start producing a sample data. We engage with the software vendors, give them the sample data, let them model it and see how it works. And most of the times, I mean, that you find what's written on the sales of that software isn't exactly how it works. So that's why you need to model different scenarios in order to make sure that it will deliver what you want or what you're expecting. Then after that, we do a pilot workshop with the client or with the software vendors, testing the data, making sure that it handles amount of data, because it depends on the size of the project. But you have a project which is a house being built, which will be a few hundred of activities, and then you have major infrastructure jobs which will have millions and if not even billions of records of data. Then we go into the implementation stage, and that's the next one here I have. And the implementation stage is, as you can see, it has a process that it follows sequentially, but it's not actually sequential because there is a feedback loop in any of these that can go back and change stuff if we find that they are not working. So first of all, you need to do the regular planning. You have to have your BIM execution plans, your engineering management plans, project controls execution plans, and all this stuff set. And when I'm saying that, they have to be written to match the BIM requirements, not only the standard project controls execution plans or engineering management plan. So it is vital and it is important for success. If you're using BIM, you need to define what the attributes you need on the BIM model, and what is called the MPDT or Master Project Delivery sheets that need to define all the attributes for each element, what we need there, what quantities we require in order to extract this quantity in the next thing. And as you can see, I mean, that system we're using here is using a very simple, something very like Excel formula, where you just give it the formulas how to calculate quantities based on the rules of the method of measurement. So in the standard method of measurement, I'm sure they cannot read that, but here it says there is a formwork plane vertical width between 0.1 and 0.2. So what we have done here is, in this we say that the face width is between 0.1 and 0.2, so it just extracts all this information or all the quantities related only to that particular element, instead of just calculating all the quantities of the formwork. Then after we do that, we do costing. So the system, this particular case, we can do resource-based estimate, where each of the items which is quantified will have all the resource backup with the rates, and then it will do a fully quantified and priced BOQs. Next step will be linking the program to the BOQ using the models again. We don't link, we don't do direct links. We link through the models. So we start linking the model elements to the program, which will create for us a 4D and a 5D simulation. And the 4D is just showing a simulation how the project is being built, while the 5D is including the cost on top of that. In the progress monitoring, that's quite interesting, because how you capture the progress from site. And there are various ways and various methods that we've used, but this is a very nice way. That's like a handheld device, an iPad or something similar to it, where you have all the items or all the BOQ items in here and activities, and when you click on them, you get also the details behind that. So you can either update on a high level saying that all the columns have been complete, or you can just go and click on each column and say, yeah, this columns 1, 2, and 3 are complete, 4 and 5 are not, or 6 and 7 we finished only the reinforcement of it. Then change integration. I mean, how many projects you've been on without single change? I'm looking for one since like 10 years, so couldn't find any. So that's the most important bit for us. So what we have to do, we were looking for a system that will integrate the change back into the program and the estimate or our BLQ and budget with traceability, which is a key for us for any success of the project. So whenever we have a change, that change affects control accounts in our structure, and then we know that the budget is increased or decreased based on it. Also, we've used the change management module to manage risk. When we have a risk contingency or a risk pot, we don't use or withdraw money from that risk pot without having to go through a change control process, even internally within a contractor or within the client. They need to go through a change control process. So the project manager needs to change a change request. It goes to the director. They either approve it or disapprove it. Then we produce all the reports from that, and then we start creating corrective actions based on the requirements. And as you can see, I mean, here that's like a typical CPI, SPI curve, and how we should be managing this and creating some actions in order to avoid problems. That's an extract from a BI tool. In this case, in this instance, it's just getting the earned value analysis matrices. So we have the budget cost of work scheduled, performed, and actual cost per work performed, and we have the historical budget, so we can compare multiple baselines. So we have the contract baseline, we have the current baseline, and you can have any other scenarios, and then you start comparing these baselines together. And the reason why we're doing that, because sometimes it's not, you don't get an immediate reflection of the compensation events into your contract, where it takes some time until you get the compensation events implemented during the negotiation and assessment of values and stuff like that. So here, I know it looks messy, but it is a comparison between different baselines, comparing them to the current and the forecasted value. We have some stuff here that it is for for future stuff that we're trying to do is about using artificial intelligence in BIM and using integration into wider systems, including human resources and recruitment, which we are currently investigating there. Using IoT, which is quite interesting because in the current project that I'm working on, we have used IoT in earthwork. So we have digitized the earthwork processes where all the equipment on site are fitted with sensors, and these sensors reports back the progress into a central repository, and that updates our progress and our program and the cost from the same source of information, which comes from automation on site. So there is no human intervention on that. And that's it for me. Thank you. And over to Dave.